All right, this is video number 3 on chapter 6, Pre-Algebra, and this is an aviation problem. An airplane descends from 44,000 feet to 23,000 feet in 7 minutes. Express its rate of change, this is important what it's saying here, rate of change in altitude in feet per minute as a signed number. So it's important on whether it's descending or ascending, right? Descending means it's going toward Earth, right? It's coming out of the sky, and that means that we're going to need a negative descent, right? Because it's on the way down. So negative numbers. Think about temperature. If you go below 0, you're going to plunge to a negative number, but this is just basically going in the negative direction. We take 23,000 and subtract 44,000. Now you could do this the other way around as long as you realize, oh, I need to put a negative on my answer to get this right. When we subtract, we get negative 21,000. So the rate of change is 3,000 feet per minute, right? A negative 3,000 feet because we were descending. So just be careful whenever you are answering these questions on your written work or on my lab that you pay attention to the fact that, oh, it was descending in this case. Okay, so this is a straight out calculation. You are just going to key this in and see if you can get it right. This is one of those cases where you definitely would have to close your parentheses on your square root. I would suggest maybe that you go ahead and put in at least some of the steps here. Maybe you just calculate what's underneath and see what that number would be. So that's going to be times 1, 2, 3, 4, 5, 6. That is 1 million times 24. Because the exponent is 6, that means that there are going to be 6 zeros. When you calculate this number, you get 7 zeros. 1, 2, 3, 4, 5, 6, 7. You can try this. You can try the calculation without writing out any other steps, but just see if you can get that. Be sure and close your parentheses. So 18973.6. We're going to round this to the nearest 1,000 ohms. And so that would be, right, the nearest 1,000 would be 19,000 ohms. And that's that one. Practice those calculations. Now on the next one, we have to put the numbers in and then do this calculation. So this one is going to be the last one for this lesson. Be careful with the fact that, right, we have it to the second power on 2 parts of this. And let's look at our numbers. Suppose that that's a subscript, right? H sub 2, the maximum roof height is 13. So this is going to go in for that. H subscript 1, the minimum wall height is 7.5. So that's my H sub 1. And W, the width of the shed, is 12, right? So there's my W. Calculate the rafter length, not including allowance for overhang, round to the nearest tenth. So we just have to get our numbers in there correctly. We are going to have 13 minus 7.5, and we square that, and then add 12 squared. You can put that in parentheses also if you want to. Anytime you substitute, you really should. But 12 is a positive number, and we can't really mess that one up. When I subtract, I get 5.5. So 5.5 squared plus 144, because I can go ahead and square the 12. And then when I square the 5.5, excuse me, it's 30.25 plus 144. And of course you can key this in once again to your calculator. You don't necessarily have to show all these steps that I'm showing, but please show some and, you know, work through it that way so that you get some practice with just the squaring of things and the fact that you are working order of operations under the radical, the square root symbol. and then we end up with 13.2 feet, and that makes sense with the numbers that we were given in the problem. Make sure that it's not some crazy number that doesn't make any sense. All right, so that's it for pre-algebra on chapter 6. Bye everyone.